Hello, this guy. A ball is attached on the end of a string, loose from rest, which means we start with all potential. And then we're going to pretend that's the ground. So it's all kinetic, and then it's all potential again. What is true for the motion of, what is true? The work done by gravity is negative. That is false. Because gravity is saying, come down, please. That's what the force is doing. And the displacement is saying, okay, I'm going down. So the work done is positive because it's the same direction. So that's not true. The work done by tension is negative. I'm tempted to say the work done by tension is 0. I'm going to put a squiggle because I'm not sure. The change in gravitational potential energy is negative. That is, that's true. Because we start with some and we end with none. That's true. The change in kinetic energy is negative. No, because we start with none and we end up with some. So that is false. Network is negative. No, because work done by gravity is positive and that's the only thing doing work. So I'm going to put C. Why was B tempting? The work done on the ball by tension is negative. So tension is like, you should go this way, but it's actually going that way every moment. So it's not negative, it's 0. That's why that's false. So that's not true. What is the speed at point B? So we start with gravitational potential, and it becomes all kinetic. So mgh equals 1/2 mv squared. Tail is on its time. G we're going to put in as G. The height, when this rotates and comes here, the height is R. Isn't that weird? Equals 1/2 v squared. We're going to multiply both sides by 2, get 2gr equals v squared. So the square root of 2gr equals v. What is the tension at B? So at B, we have tension up and we have mg down. And we know that the sum of the forces equals ma, but it's a special kind of A. It's centripetal acceleration. So tension minus mg equals m, and then AC is v squared over r. We're wondering what is the tension. Okay, so T equals mg plus m v squared over r. But for v, I'm going to plug in this root 2gr. So this is root 2gr squared over r. So T is mg plus m. The square root of 2gr squared is just 2gr over r. Well, the r's cancel out. So T is mg plus 2mg. So that ends up being 3 mg's. Isn't that weird? That's good. That's satisfying. I like that one. What is the tension at point C? Like we need to change colors. There's a lot happening. At C, what? Okay. The tension is the only center-seeking force. So the sum of the forces in the direction of motion is MAC tension equals m v squared over r. The v squared is 2gr over r. T equals m2g, 2mg. I think that's it. Let me check the answer key. Okay, the answer key says the answer is 0. Why is the tension at point C 0? Is it a pendulum or like a whipping it around? Okay, if it's a pendulum that's literally going like woohoo, 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 then yeah, tension here is 0 because it's about to fall back down again. What's a physics reason why that's true though? Nothing is center seeking anymore. The only net force is gravity down. I don't like that. What about, what else is going on? Tension was 3 mg here. We had 3 g's. Why did it go to 0? Tension 4 equals ma. Is there no more center-seeking acceleration? Work is force times displacement. Is that the moment where it freezes in time before it changes direction, so its displacement is 0, so the force is 0? I don't know why 15 is A, I'm sorry. I would have got that one wrong. But you know what? You don't need all the points to make a 5. I'm sorry.